So, maybe. Oh, my pencil's dead too. This is a good day. Hold on. I'll just write it. Two angles whose sum is equal to 180 degrees. Okay, and the word was supplementary angles. Okay, our drawing, you could have just a straight line, angle 1 and angle 2. Okay, those would be supplementary angles. Or you could have them disconnected. If this was, let's say, 115 degrees and this one was 65 degrees. Okay, those angles are supplementary as well because they add up to 180. Okay, key thing here, supplementary angles do not have to share a common side. Okay, so they add up to 180, but they do not have to share a common. Questions on supplementary or complementary?
So these also don't share a common side?
They don't have to. So yes, this could just say complementary angles. Complementary angles do not have to share a common side. The way that some of my students remember complementary and supplementary. CO for complementary, corner, and a corner is always 90 degrees. Supplementary starts with an S, so straight. Okay, and your lines are always 180 degrees. So if you want to remember those two tricks, that's fine. I even had a student one year tell me that when you write 90, you start with a C, and then when you write 180, you have an S in there. If that helps you, I don't know. But I had a student tell me that once. Questions on supplementary or complementary? Okay. I think we're back in business on the iPad. Next one, adjacent angles. Adjacent angles. What do you think it means for something to be adjacent? Yes.
Does that mean that they share a side?
They share a side, okay, or they're right next to each other. Okay, so two angles. If they share a common side, what else do they have to share? Correct. It'll be a ray, but what else? And what else? Angle, but vertex, more specifically. Okay, so two angles that share a common side. And common vertex. Okay, so if we draw our picture. This would be your common side. And this would be your common vertex. Questions on adjacent? Okay. Next, linear pair. A linear pair. What do you think a linear pair is? Based off the words, yes.
Two rays that you put together will form a line.
Okay, not just two rays, but what do you think? These two things do form a line, but what do you think?
2 points.
Angles. Two angles. Very good. Okay, so two adjacent angles. What does adjacent mean? Share a common side and a common vertex. So two adjacent angles. That have non-common sides, and I'll explain that in a second. Non-common sides that form a line. Okay, what it means by non-common sides, okay, so you have adjacent angles, so you know that they have to be next to each other and share a common side, but then the two non-common sides form a straight line. Okay, so you have your common side that makes it adjacent, and then two non-common sides that form that straight line. So what is an example of a linear pair in this diagram? Which angles? Not 2 and 3. Those are across from each other.
1 and 2.
1 and 2. What else?
2 and 4.
2 and 4. What else?
4, 3.
4 and 3. What else?
1, 3.
Very good. 2 and 4. 4 and 3. And 1 and 3. So there's 4 sets of linear pairs. Yes.
Are they always right angle?
No. They can be anything. Like that could have been 179 degrees and 1 degree. It does not have to be right angles. Questions about linear pairs? Okay, next one is vertical angles. Vertical angles. Okay, vertical angles are two non-adjacent, which means what? If they're non-adjacent. Not necessarily the same vertex, but the same line. So they do not share a common side. Okay, so two adjacent angles formed by two intersecting lines, line segments, or rays. Okay, what do you think would represent a pair of vertical angles? So they can't share a common side, and they're formed by two intersecting lines. Yes?
3 and 2.
1 and 3.
1 and 3, and what would be the other example?
2 and 4.
Very good. Okay, your vertical angles are always across from each other. Okay, they're always across from each other. Okay, here is my question for you. What angles are vertical angles in this picture? Think about your definition and then look at that picture. Do we have vertical angles? What do we think? Raise your hand if you think yes. Raise your hand if you think no. So a whole lot of no hands. Okay? Two non-adjacent angles formed by two intersecting lines, segments, or rays. Do we have intersecting lines there?
Yes.
Do we?
We'll check it out.
If they share a vertex, they're not intersecting. Okay, if these were lines Intersecting lines, they would be straight. Okay, so those are not intersecting lines. They're just a bunch of rays or segments stemming off of a vertex. They do not intersect. So don't make the mistake of saying 1 and 3 and 2 and 4 are vertical angles. They have to be intersecting lines, segments, or rays. Okay? So if you want to draw that non-example, you can. But those are not intersecting lines, so there's no vertical angles.
I didn't think so, but I wasn't 100% sure. I really wanted to be wrong.
Gotcha. Okay, next one, review from last class. Postulate. What is a postulate? We talked about it last class with Euclidean and non-Euclidean geometry. What was the postulate?
Statement that is taken as true without proof.
Awesome. A statement that is accepted without proof. So we don't have to prove that 2 is 2. A statement that is accepted without proof. Okay, so these next terms are all going to help us and lead us into 2.3, which is for you guys on Monday. Okay, and this is when we start writing our 2-column proofs and all of our formal reasons. Okay, so our next one is theorem. What is a theorem? We talked about this along with postulate. Opposite of postulate, what's a theorem?
A statement that can be proven.
A statement that can be proven. Okay, so we can prove whether 2 lines are parallel or whether 2 lines are perpendicular or the distance formula or Pythagorean theorem, all those good things. Okay, we can prove all of those. Questions on postulate or theorem? Okay, the next one is Euclidean geometry. Is what we're doing right now Euclidean? Everything you've known up to this point, is that Euclidean or spherical? Euclidean. Very good. Okay. Everything we've done up to this point is Euclidean. What's the difference between Euclidean geometry and non-Euclidean or spherical? What was the essential difference? Very good. The nature of parallel lines. Okay. On your sphere, okay, or spherical geometry, what do they call the lines in spherical geometry?
Great spheres.
Great circles.
Great circles. Very good. Okay, great circles. And what do we know about great circles?
They intersect at 2 points.
Very good. They always intersect at 2 points. So why are there not parallel lines in spherical geometry?
Because all lines intersect.
Very good, because all their lines intersect. If great circles represent lines and great circles intersect, then there's no parallel lines in spherical geometry. What was the third talking point for spherical geometry, Madhu?
The triangles have a sum greater.
Very good. The triangles can have a sum greater than 180. So spherical triangles, interior angle sum may be greater than 180. Very good. Okay, our definition for Euclidean geometry: the system of geometry developed by Euclid. If you miss this on the vocab quiz when Euclid is in the definition, I'll be very mad. Okay, last three. The last three is what is going to really lead us into this 2.3 section. Okay, the first one is the linear pair postulate. How do linear pairs differ from supplementary angles? They both form straight lines, but what's the difference? The linear pair has to be adjacent. Supplementary does not. Linear pairs have to be adjacent. Okay? So if two angles form a linear pair, then the angles are supplementary. Okay, and you can just draw a pair of linear angles. All linear pairs are supplementary. But not all supplementary angles are linear pairs. Okay, so all linear pairs are supplementary because they all equal 180 degrees, but not all supplementary angles are linear pairs because they can have what? Why are not all supplementary angles represent a linear pair? Because what?
They cannot share what?
Very good, because they cannot share that common side. Okay, so that is why not all supplementary angles are linear. Okay, last two. Segment addition postulate. Segment addition postulate. Okay, the definition is going to sound really wordy, but I'll explain it as soon as we're done writing it. If point B is on line segment AC and between points A and C, then segment AB plus BC equals AC. So like I said, super wordy, but all it means is this. You have the segment AC. You have B on AC somewhere between A and C. Does it have to be the midpoint? No, just between. Okay, and all that this is saying is that AB, so this part, plus this part equals the whole part. So AB plus BC equals AC. That's all that it's saying. So because of the segment addition postulate, AB plus BC equals AC. So you could have a problem that said if DF is 20 and DE is 9, what is EF? And it could be DEF. So if DF is 20 and DE is 9, what is EF? 11. So just simple. 11 plus 9 is 20. Questions on the segment addition postulate? Okay, last word. Angle addition postulate. Angle addition postulate. Okay, it's very similar. Okay, if point D lies on the interior of angle ABC, then the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. Okay, once we draw it, it'll make more sense. We have our angle. Okay, we're going to have point D somewhere in the interior of our angle and draw our ray through it. I don't know why it's not wanting to draw. Okay, there. Okay, if we label our points A, B, and C, this is 21 degrees and this is 44 degrees, let's say. Okay, ABD, which is 21 degrees, plus 44 degrees would equal our total angle, which is how many degrees? 65. Okay, so that's all the angle addition postulate says. Just that two angles can be added to equal the total angle. Okay, any questions on our vocab that we did today? That was the last one. Pretty easy? Okay, next thing then, notes. These won't take very long. All right, first one. Calculate the measure of an angle that is supplementary to KJL. What do we know about supplementary angles? Very good. They have to add and get 180. So if I have a 22 degree angle, how can I find the measure of the supplement? Very good. 180 minus 22. And what do we get? What is it? 158 degrees. So the supplement to 22 degrees is 158 degrees. Okay. Number 2, determine the angle measure in the diagram. What do we know about those two angles? They're supplementary. So how would you solve for x?
Add them together and equal them to 180.
Very good. Add them together and set them equal to 180. You do not set them equal to each other. Okay, they are not congruent angles, they are supplementary angles. Combine your like terms. What'd you guys get for x?
50 degrees.
Okay, it says to determine the angle measures. Okay, so what do you need to do? Substitute 50 in for those two angles. Okay, so for one of them you have 50 minus 30 degrees. And the other one you have 3 times 50 plus 10 degrees. So what is the measure of your two angles?
20 degrees and 160 degrees.
20 degrees and 106 degrees. And then you can always double check your work because you want to make sure that your two angle sum is indeed 180. Okay, the next one, two angles are supplementary. Okay, let's draw a picture. Two angles are supplementary. Okay, the smaller angle is 40 less than the larger angle. What is the measure of the larger angle? So how would we represent 40 less than the larger angle? x minus 40. What would that make our larger angle? X, because that's what you're comparing to. Yes.
I already think I know the answer.
It's okay. We're going to still work it. Okay, so you have x and x minus 40. Okay, now that I have those two, how do I solve for x? If they're supplementary, how would I solve for x? How would we solve for x? Add them together and what? Set them equal to 180. Guys, we just did it in number 2. I should have way more feedback than that. So I have 2x equals 220. X equals 110. So what is the measure of our larger angle?
110 degrees.
Very good. 110 degrees. Questions on 3. Okay, so with that in mind, I want you to do the next page. It's about complementary angles. Okay, it's the same three styles of questioning, and then we will go over them. So do the complementary page. Okay, what do we get for number 1? What's the complement of 62 degrees? 28 degrees. 90 minus 62. Okay, number 2, what did you guys get for x first? 28 degrees, very good. And so what were each of your angles? 14 and 76. Do we agree? Okay, at the bottom, number 3, what was the measure of the smaller angle? What were your 2 equations first? What were your 2 equations? So if I have my complementary angle, well, how did I denote my smaller angle? X, and what was your larger angle? 2x. Okay, so you had 3x equaled 90. So x equaled what? 30. And so what was the measure of your smaller angle? 30 degrees. You guys got to get more lively. We need way more participation. Okay, turn the page. Okay, we are going to go through and determine whether these are adjacent angles or not. Okay, so starting with 1 and 2. Are angles 1 and 2 adjacent? Yes. Are angles 3 and 4 adjacent? Yes, they share a vertex and a common side. Is 5 and 6 adjacent? No. Are 7 and 8 adjacent? No. Questions on adjacent angles? Okay, linear pairs. Are 1 and 2 a linear pair? Yes. Is 3 and 4 a linear pair? Yes. Do they share a common side? Yes. Do they form a straight line? Yes. Okay, 5 and 6? No. Why not? Very good. They don't share a common side. 7 and 8? No, why not? They don't share a common side. What kind of angles are 7 and 8? Vertical angles. Okay, questions on linear pairs. Okay, moving right along then. Vertical angles. Are 1 and 2 vertical angles? Yes. 3 and 4? 5 and 6? No, why not?
Because they don't have straight lines.
They're not straight intersecting lines. Okay, 7. Points A, B, and C are collinear, and B is in between A and C. If AB equals 3x plus 11, BC equals 6x plus 2, and AC equals 7x plus 3. What is the value of x? Okay, so here's our number line, or our line segment. So B is between A and C. AB is 3x plus 11. BC is 6x plus 2. And our whole thing is 7x plus 3. Okay, how would you solve this problem? Peyton?
I think you would add the A and B and then B and C and then equal it to 7x plus 3.
Very good. Okay, so she is correct. You would add 3x plus 11 plus 6x plus 2 equals 7x plus 3, and you would solve. Okay, however, the numbers that we chose don't even work with this problem. So when you solve it, you actually get a negative number, and then you'll get a whole bunch of negative side links. Okay, so this problem is not written well. However, you do need to know the process of how you would find x. So you would add your two segments together, set it equal to the whole. Okay, I believe when you do solve, you get x equals negative 5, I think. And obviously that's not going to work out real well. Okay, so that is the segment addition postulate. Okay, angle addition would be very similar. Okay, we didn't put practice problems on here about that, but you will find those on your homework. Questions over anything today? No. Okay, in your baskets, there are sticky notes. Okay, it's not a grade, but I am going to do a little exit ticket to see where we're at after today. Okay, so on your sticky notes, answer the following questions. Make sure you put your name on it. Okay, number 1.
Will the other parts work?
No,
The sticky notes. Do the sticky notes. Number 1. Find the complement of 32 degrees. 2. Find the supplement of 102 degrees. You can just write the answer. 3. Vertical angles are always blank. 4. Draw that little picture. You don't have to draw it super big. If this angle is 25 degrees, label the remaining 3 angles. So what is this one, and this one? And then last but not least, number 5. Okay, we just need to know for class size purposes how many people are planning on dropping out of pre-AP. So it's just, are you staying? So you write staying or you write dropping. Staying or dropping pre-AP GO. Okay, so this is just so that we can get an idea for class numbers, seating charts for the next 6 weeks, getting your folders for all your tests and quizzes and all that stuff set up. We just don't want to waste folders if you have intentions of dropping and I just maybe don't know. Okay, and nobody's going to see these except for me. When you're finished, you can just hold it up in the air and I will come collect them. All of them. So just draw that little picture and just fill in the blanks. Finished?